statistics because the respondents who were full-time college students aged 18 to 12 are a sample of the entire American. So they are just a sample, which means the parameter 66.4, the number 66.4 is a sample. It's a simple question. So let's go to question number 2. You have to be careful with this kind of question. They're asking about comparison. So a cell phone company monitors monthly phone usage. So these people, they are monitoring monthly cell phone usage. The following data represent monthly phone use in minutes of one particular customer for the past 20 months. Use the given data to answer parts A to B. Okay, so these are past, this is for 20 months actually. So it's trying to tell us that the sample size is 20. Another way of telling us that the sample size is 20. Okay, determine the standard deviation and interquartile range. Okay, you already told that you're looking for sample standard deviation. S means sample standard deviation. Also, remember that IQR, we talked about that last class. IQR is interquartile range. Okay, so put this data in your calculator. A data like this is actually it's not simple enough for you to do by hand. And by the way, there's going to be 20 questions in that test. You have 90 minutes, so you try to make sure you have speed and accuracy in that test. You have speed and accuracy. The test will be in 2 days. So I'm going to go to start and type that data in. I have already typed this data in my L3, and I'm going to look down and see if anything looks fishy there. Okay, there was a time we were told to change. I'm going to change this 0 to 326. Very soon now, you will know why it was changed to 0 before. So I changed it to 326. So type this data in your calculator, or if you don't have time now, you can do it later, but we want to answer the question. Okay, so there is a corner to that question. Suppose the month in which the customer used 326 minutes was not actually that customer's phone number. So he used another person's phone number and used 326 minutes. That particular month, the customer did not use their phone at all. So actually, we are going to change 326 to 0 after we do the first one. How does changing the observation from 326 to 0 affect the standard deviation and interquartile range? Okay, how does it affect the standard deviation and interquartile range? What property does this illustrate? So I'm going to go to my calculator and do one variable stat of L3. This data is in L3, and I want to make sure I arrow down to make sure there are 20 of them. I'm given the sample size of 20. So I want to make sure there are 20 of them. All right. So this is the 20th number. And then it's asking me for the 21st number. So there are 20 of them. And I need the sample standard deviation. So I will go straight to finding the one variable stat of this data in my L3. Data is in my L3. So I'm going to start, arrow to calc, one variable stat of the data in L3. I want everybody to look. My list is saying L1, so I have to be careful. So I want to make sure that I put L3 there because the list is in L3. The list is in L3. Okay, and this data is a raw data. Therefore, I cannot have frequency. It's a raw data. So I'm going to clean that. So I'm going to clean alpha 1. If I do alpha 1, the digit gets away. So actually, but I don't have to put anything there. So I took the number out. So I'm going to calculate. So calculate. I just calculated and I found that the mean is 416.25. Nobody's asking me about the mean, so I don't even need the mean. But I need the sample standard deviation. I'm told to find the sample standard deviation to 2 decimal places. So the sample standard deviation is 78.42. So sample standard deviation is 78.42. I'm going to be cleaning all this. So I'm going to clean all this so I can use the space to answer the question. Okay, so sample standard deviation I found to be 78.42. So let's look at it again. 78.42 is the sample standard deviation. Okay, so I will put the sample standard deviation here. Sometimes you will see something like this too. It's 78.42 to 2 decimal places. Okay. Also, let me see what else I'm told to find. I am also told to find in that data, I'm also told to find interquartile range. So I can find them from the same place. I did one variable start. So all the 5 numbers somewhere are there. So this is 5 number summary. This tells me that the sample size is still correct. But remember that interquartile range is Q3, third quartile, minus Q1, first quartile. So 486 minus 342.5. So I'm going to have approximately 143.5. But let's do that so that I can just put 486 here. 486 minus 342.5. Just to make sure, 143.5. So I found the interquartile range as 143.5. So I just have the, okay, so this is interquartile range 143.5. I'm going to pull my, so IQR is 143.5. That is Q3 minus Q1. Is 143.5. Okay, but there was a problem in this question. They told us that actually the number 326 needs to be changed to 0. So I will go back and look for 326. And wherever I find it, I'll change it to 0 because the customer actually did not use his phone that month. So change it to 0. And I hit enter. So 326 has changed to 0. I will do one variable start of this again. When 326 is now changed to 0. So I will go back and do one variable start. Start calc, one variable start of L3. Remember that my data is in L3 and this is not a group data, so frequency list has nothing there. I'm going to calculate one data, one number, one individual. One individual changed, okay, from 326 to 0. So let me see how it affected the standard deviation and how it affected the interquartile range. So the standard deviation right now changed from, wow, it changed from 78.42 to 120.67. So the new standard deviation The new standard deviation is 120.67. New standard deviation is 120.67. Okay, let me see the change affected interquartile range. So I'm going to go down. All right, so interquartile range is Q3 486 minus 342.5. So actually, it did not actually change. So the current IQR is still 145.5. So the change in the number affected the standard deviation drastically. So we said that standard deviation is easily affected by any change in data, easily affected by any change. It did not change the interquartile range, it changed standard deviation. Okay, so I'm now going to answer the rest of the question. Okay, suppose the month, okay, we answered that. So the measure of dispersion, which is standard deviation, changed drastically. So the standard deviation changed from here, an interquartile range was that. The property, this illustrates, choose the correct answer. The property, it affected the measure of dispersion, which is the standard deviation. The smaller, see, we changed a number and it increased the standard deviation. Therefore, the interquartile range is resistant to the change, but despite it's not the standard deviation is not resistant. It actually increased the standard deviation. The interquartile range is resistant to change, to any increase or decrease. So let's see what the standard deviation was affected. So it is not resistant. The measure of dispersion was affected, but interquartile range was not affected. It is resistant. It is resistant to that change, big change. Okay. Everybody already knows how to draw a 5-number summary or interquartile range. So, but if you are given a question and you don't seem to find an answer in the options given to you, I advise you to draw your own, so you can draw your own box plot. So let me draw a box plot of the data. I'm going to minimize this. So I'm going to draw a box plot of the data so I can compare it with what I'm given. The lowest number is 60, the highest number is 100. So I can just use that. If you have a ruler, you can use it. So this is 60. This is 100. And according to so my left whisker stops here. And the the first quartile is 68. The median is 77 somewhere. The maximum number is 89. And it's not maximum, I mean, I'm talking about the third quartile is 89, and the maximum number is 98. Maximum number is 98. It's 98. Okay. And if this is 98, I just want to use my own. So I put this is my third quartile, and this is my maximum number. It may not look like what you're given, but the important thing is that I need to, in fact, if you find the difference between here and here, let's say that this is approximately 9. If you find the distance between here and here, it is longer. This distance is longer. So the median will be somewhere there, a little bit. And the upper bound here is approximately this distance is 8, and this distance is almost 9. So the box plot of the data is the one I just drew. Then I will try and pick the right one from the data. Okay, so this is not a big deal. You can draw the box plot. Okay, so this question number 4 says, suppose babies born after a gestation, that means they have been in the stomach, their mommy's stomach for between 32 years and 35 years, has a mean of 27 grams, 2,700 grams, and standard deviation of 900 grams. So let's write this information down. I'll pull my whiteboard again. I'm going to pull my whiteboard again so that, okay. And I'm going to divide this into 2 because I'm going to compare apples and oranges. Whenever I'm doing z-score of two things that have different standard deviations, I can't compare them unless I found the z-score. So I want to remind myself that z-score is value minus mean over standard deviation. Value minus mean, hopefully it is a population. Okay, so we want to say that babies who are in the womb from 33 to 35 years are A, let's call them A, and babies who are in their mommy's womb for 40 weeks and above, which means greater than or equal to 40 weeks. 40 weeks. Okay, we want to see what the standard deviation and the mean is. So let's get the mean. The mean of those who are here is 2,700. The standard deviation of those who are between 33 is 900. Okay. The mean of those who are babies who are in the stomach for more than 40 weeks is 3,300. So this is 3,300. That's the mean, 3,300. I can just use X bar or mu, 3,300. And the standard deviation is 400. Standard deviation is 455. While the standard deviation here, I'm going to call this one S1, S2. Call this mean, mean 2, mean 1. So that way. Okay, so we have enough info, a little bit. We need one more. And then we can pick a baby, a particular baby in the one that stays 33. So a particular baby stayed 33 weeks in his or her mommy's womb. And when the baby was born, he weighed 3,000 grams. So this baby weighed 3,000 grams. And a baby born 40 weeks weighed 3,300 grams. 3,300 grams. So the question is, which baby out of these two? The question is, which baby weighs more relative to the gestation period? In relation to their gestation period, which one weighs more? we cannot compare using the numbers given to us here and here. That's not the, we don't need to use that to compare. We will compare after the z-score. So let's find the z-score first. So we're going to find the z-score. I'm going to clean the spot. So z-score for baby 1, so z1 is the weight. The weight, what is the weight of that baby? The weight was 300. The weight 3,000 minus 2,700, which is the mean, over standard deviation of babies that weigh between 33 weeks to 37 weeks. And that standard deviation is 900. Okay, I'm going to write this one here. The Z2 is the weight of a baby born after 40 weeks. And the standard deviation of, and the mean, by the way, the mean of babies born here is, let's see, the mean of the babies born here. Let's see what their mean is, because we need to, okay. So the mean of the babies that are born is 3,000. So let's make sure we change it. So this is 3,000. That is the baby born. Okay, so we put 3,000 there. And then we know that the standard deviation of babies born, babies who stay more than 40 weeks in the womb, have a lower standard deviation. Note it here. Those who stayed less than 40 weeks has a very high standard deviation. This one has a low standard deviation. Okay, so now we are about to calculate which one weighs, which weight is higher. Is it a baby that was born at the weight of 3,300 and was born 40 weeks after, or the baby who was born 33 weeks after and then weighed 3,000 grams? Let's check that out. So we're going to pull my calculator up. Okay, and we want to find the weight, the z-score of the baby that was born 33 weeks after. That 3 weeks is less than 40. So we have 33, this is 3,000 minus 2,700 is 300. 300 divided by 900 is 1/3 or 33%. So I can just say that 33%. Let me write percent so that 33% here, or 0.33 or 1/3. So I'm going to find the z-score of the baby that was born 40, that stayed 40 weeks or more in the stomach. Okay, and then that is 300 minus 300 is 300. So 300 divided by 455. So 300 divided by 455, and that is 0.66 approximately, which is the something as 66% if I'm changing it to percent. I don't have to, but 0.66 or 66%. Therefore, the question is the way to answer this question is which z-score is greater. Therefore, the higher z-score is 66% or 0.66. Therefore, the baby that weighs that was born after 40 weeks gestation has a higher weight. The weight is higher. Okay, so we answered that question. So, but you have this kind of question, application of z-score. This is application of z-score. And then let's see if there's another question. Find the corresponding z-score. Which baby weighs? Okay, we already found that. Okay, the next thing we want to do is make sure we answer question on group data. So let's go to group data right now before we, so we're going to answer question on group data. We already talked about parameter and statistics. Somebody's always going to see if you know the difference between parameters and statistics. A parameter is a characteristic of population. Statistics is a statistics of a sample. Okay, something like sample mean. Sample mean is X bar. Population mean is mu. Okay. Sample standard deviation is S of X. Population standard deviation is sigma X, and so on. You want to make sure that you put the correct answer where it should be. Okay, so the next question is group data, because we want to make sure that we review group data. Even though we have done it before, but we need to review group data again, making sure we know how to do it. All right, grouped data. All right, let's look at this number. Number 18 is the group data. And the data given to me actually is horizontal. Whenever I'm given a data that is horizontal, I know I said it before, but it doesn't have to say it again. Whenever I'm given a group data that is horizontal, I will change it to vertical. A group data that is horizontal, I need to change it to vertical. Okay. Okay. So, so what I want to do now is change the data to vertical so that change this data to vertical. So this is the class or classes, and I want the middle to be frequency, and I must find the class midpoint. So I might as well start writing it now. Class midpoint. I could also be told to find the relative frequency. I could be told to find the relative frequency. Remember, the relative frequency of any class is the frequency of the class over the total. Okay, let me look at the data again in this question number 18. Let me start writing the classes. The classes are from 50 to 59, 60 to 69, 70 to 79. So let's do that. So 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99, 100 to 109. Okay. Okay, now I'm going to get the frequency of each class. So going to get the frequency of each class. The frequency of the first class is 3. First class is 3. The frequency of the second class is 324. The frequency of the third class is 1499. So 1499, 1518, 1499, 1518. The frequency of the second to the last class is 271, and the last one is 12. 271 and 12. So the next thing, because this is a group data, I have to find what is called a class midpoint or class representative. So I have to find the class midpoint. Class midpoint is always the lower limit plus upper limit divided by 2. What do I mean by lower limit? This is the lower limit of the first class, 50. So I put 50 here. The upper limit of the first class is 59. Then I divide it by 2. 50 plus 59 is 109. Divide 109 by 2, I have 54.5. So the class midpoint of the first class is 54.5. And by the way, if I look at this data, I see that the class weight of each class is 10, class weight or class size. So if I can only point, all I need to do is keep increasing that with the class weight. Well, let's find the second. So second class midpoint is going to be 60 plus 69 divided by 2. And if I find it, I will see that it's 64.5. 64.5. The distance between the first and second one is 10. So that tells me that the consecutive class midpoints differ by class weight. So 74.5, 84.5, 94.5, and 104.5. So classes differ. Class midpoints differ by consecutive class weight. Just in case I'm told to find the relative frequency, then it means I have to know the total frequency first. Find the total frequency. And then if I'm told to find the relative frequency of the first class, then it is the frequency of the first class over total frequency. But I haven't found that. I'll soon find it. Total frequency. Data in my L1, but let me see if anybody has any question. Okay, so I am going to put this data in my L1 and so put the data in my L1. Okay, and the data is in my L1, which is class midpoint in my L1. Frequency is in L2 because I have already put it in there. So I have already put it in there. The class midpoint in L1, frequency in L2. Whenever you have a group data, class midpoint will be in L1, frequency in L2. Okay. Now, the next thing you want to do is to find the one variable stat of a group data. So go to stats, find one variable stat of this group data. Okay. Find one variable stat of the group data. All right, so I am going to find the one variable stat of the group data. My data is in L1. In other words, class midpoint is in L1. Frequency is in L2. Why am I talking about frequency? Because this is a group data, and then I'm going to calculate. So let me see, but I have already found the class midpoint, and I found the mean. Let me see what else the question is asking me to do. What else is the question asking me to do? Okay, approximate the mean is the mean of the population. So the mean of the population is to one decimal point is 79.4 approximately. So the mean is 79.4. And what about the standard deviation? 7.8. The mean is 79.4. So the mean, remember that this is a population. So the mean is 79.4, and the standard deviation of this group data that is actually a population is 7.8. Okay, and what else I told to find in this data? So I'm just going to go back and see all the things I'm told to find. I found the mean, found the standard deviation, use the frequency histogram of the data to verify that the distribution is bell-shaped. Let me open it. I looked at this distribution. It looks like it's bell-shaped. But as a statistics student, let me find if it is actually bell-shaped. In other words, is the mean equal to the median? So let me go back to my calculation. So I found that the mean is 79.4. Is the median the same? No, median is 74.5. Therefore, this data is actually skewed right a little bit. It's approximately, you can say it's approximately normal, but it's skewed right. Okay, but anyway, I'm told to find, so this is the histogram, and I can find I can say it's approximately normal. It's not normal, but it's approximately normal. The mean and the median are near enough. Okay, but I'm told to find, use it to answer empirical rule question. C says, according to the empirical rule, 95% of days in the month will be between what temperatures? Very easy question. So let's get my, how do we answer this question in a test? So I'm going to clean this board a little bit. That way we can answer this question. We want to make sure you know how to answer this question. Okay, we talked about it last class. You can use calculator, but you can actually do it by hand. Okay, so the empirical rule says that 68% of data, 68% of data lie within plus or minus 1 standard deviation. 95% minus standard deviation, and 99.7 lie within plus or minus 3 standard deviation. Okay, so now I am told to find the data lying within 95%. In other words, I should draw a line here. Mean, the right-hand side of this line is mean x mu plus 2 times standard deviation. The left-hand side of this line will be mu minus 2 standard deviation. Okay, so now we can do that. I can just go to my calculator and complete that. So I'll get my calculator. And the mean is right there. So I'm going to clear. I can just store the mean in my calculator. So 79.4. I'm going to store in X. Okay, so this is X. Whenever I put X now, X, 79.4 will come. All right, so I want to add 2 times standard deviation to my X. So X plus 2 times whatever it is in there. Standard deviation is 7.8. 7.8. And I have an answer. So the right-hand side is 95. Okay, let me get the left-hand side. So I'm about to get the left-hand side. Remember that I already stored the mean in my, so all I have to do is second enter. And then I'm going to subtract 2 standard deviations from the mean. So I'll have to change the sign to negative. So the mean minus 2 standard deviations gives me 63.8. So the tail end of this number line is 63.8. Therefore, 95% of the data lie within 63.8 and 95. 95% of data lie within two standard deviation, and within means plus or minus. So don't forget that within means plus or minus. So 95% of data lie within 95 of that data and 63.8 of that data. Okay, so just making sure we review empirical rule. We already reviewed. Let's talk about z-score again. We did it before, but let's talk about it again. Z-score. So we have reviewed empirical rule. We reviewed grouped data. So you make sure you answer questions on group data. Make sure you can answer questions on group data. Okay. We don't like this question. So let's see. And that question is an empirical rule. So let's look at that question. This question says a highly selective boarding school will only admit students who place at least 1.5 standard deviations above the mean. So it's always good to draw a diagram, normal distribution. A highly selective boarding school. Let me make this. Okay. Okay, so a highly selective boarding school will only admit students who place at least 1.5 standard deviations above the mean. Okay, so the first thing is to, any question on normal distribution, you draw a normal curve. So draw a normal curve. 1.5 standard deviation is above the mean is right here. You can use empirical rule. You can use the empirical rule, but I also showed you how to use your calculator the other day. Above the mean. Okay, a highly selective boarding school will only admit students who place 1.5 standard deviations above the mean, okay, on a standard test that has a mean of 300. So the mean of this test is 300. The mean is always at the center. And the standard deviation is 20. So the standard deviation is 20. It's approximately normal. So let me assume that it is population. What is the minimum score that an applicant must make on the test to be accepted? You can do this by what is the minimum score? In other words, you can actually answer this question without your calculator. So minimum score you can accept is the mean 300 plus 1.5 times standard deviation. That's all. You can do it by hand. Okay, if you multiply 20 by 1.5, you actually get 25. So 300 plus, is it 25? That's 30. All right, so 1.5 times 20 is 30. So the minimum score that somebody is going to score to get a scholarship is the score that corresponds to 1.5 standard deviations above the mean. In other words, 330 corresponds to 1.5 standard deviations above the mean. Alternatively, you can decide to solve this with your calculator. I showed you how to use your calculator. So area to the right is what you're told to find. And whenever you're told to find area to the right, then you're looking for a raw score. Your calculator can do raw score. So the number here is 1 e to power 99 because your calculator does not explain infinity. That is the only way it explains it. So what you want to do is normal cumulative density function, lower bound. The lower bound is actually it is 1.5 standard deviation, but I already know it is 330. Or I can convert the mean. I can use raw score. I can use so I can actually use the mean. The lower score is 330, comma. The upper score is infinity. The mean is 300, and the standard deviation is 20, 20, 20. All right. So I'm about to use my calculator with the raw score. After using my calculator with the raw score, I can do it with standard score also. It doesn't really matter if you do it with raw score or standard score, you get something. Okay, so remember to get normal CDF, you get to second distribution number 2. The lower bound is 330. I'm using raw score right now. Lower bound is 330 because it is lower than infinity. The upper bound is infinity. Remember to put infinity. 1e to power 99. 1e is above comma to power 99. The mean is 300. The standard deviation is 20. I want to see if I get the same answer. And when I hit enter, I get I have a 0.0, let's see. So this is the area. I say, and I'm looking for, actually what I'm looking for is I don't even need all that because I already found and the area to the right of that is 0.066. But I don't even need that. I already found the number is 3. The number corresponding to 1.5 is 330. The number corresponding to 1.5 is 330. Therefore, a student can get a scholarship for this school if he scores 330 in that test. A student can get 300 scholarship. 330. Very soon we shall be asked about area under the normal curve, but I don't think we shall get to percentile. But when we get to unit 2, we still have to do percentile. That way, when you are told to find the percentile, you can quickly find percentile. I just want to make sure that we answer one question on percentile. So I am going to get that other worksheet in okay. Anytime you're told to find the z-score, it means you're looking for percentile. So use the standard normal distribution to find the z-score. So all you have to do, you the same normal distribution. P20 means 20th percentile. P83 means 83rd percentile. 0.8 means 80th percentile. So I just want us to know that whenever the question is asking you about percentile, it actually means, okay, when a question is asking you about percentile, see where is the draw? Where is the draw here? Okay. Okay. Looking for. All right, let's go home. Let's go looking for the draw sign here. Okay. Anyway, so I'm going to get my calculator quickly, and I'm looking for any time I'm told to find percentile. I can find it with chart. I can find it with calculator. Let me show you the calculator part. Calculator part is actually easy. So you will do inverse norm for now. inverse norm. That's if you're told to find the 80th percentile, change 80th percentile to 0.8, area to the left in decimal. The mean of that data, if the mean is 0, standard deviation is 1. Don't have to put them, but so inverse norm is in your calculator. So you go there and you can just the second, and then inverse norm is number 3. The 80th percentile is 0.8, area to the left. And the mean of a standard normal is 0, standard deviation is 1. And I'm going to calculate. So actually, whenever you're doing inverse norm, you're looking for z. Z can be negative or positive. So the z-score can be negative if it is below the mean, or positive. But anyway, inverse norm is what we're going to use, but it's not in this test. It's just making sure that